So we have here an uniform cylinder of length 1 meter. Okay, this is cylinder. Contains a mixture of 3 gases: hydrogen, oxygen, carbon. So this cylinder. This is cylinder. Hydrogen, oxygen, and carbon dioxide. The ratio of moles be 1:1:3. Find the time taken by the signal to travel across the length of cylinder if the temperature of mixture inside the cylinder varies linearly from T1 to T2. So this is the cylinder. So what is the type of medium? It's a gaseous medium. So the sound wave is going to propagate through it, where it's like a mixture of gases is present. At the same time, the temperature varies linearly. This is the condition he has given. So he's asking us to get the time of propagation or the propagation time, how much of time the wave will take to traverse the length of the cylinder. Okay, I think that this much is what the question that is asked for us. Okay, now first of all, their moles, number of moles. So and what about this? These are like shall I say diatomic gases? Hydrogen, oxygen, carbon dioxide. Okay, then there's a linear polyatomic will become similar to that of diatomic gas only. So let the number of moles, let it be 1:1:3 is given. So N1 equal to N, N2 equal to N, and N3 equal to 3N, I'll write it. Then what is the speed of sound? We know there's a formula. If you can recollect, V equal to gamma RT by M, where M, capital M, is the molecular mass. Then we need gamma of a mixture and the molecular mass of a mixture. If you know this, then we can further proceed. So how to get a gamma? For that, we should know CV of a mixture. This one, so what is CV? It's a that of mixture here. Specific heat of gas at constant volume. So what you should call CV? Specific heat of gas at constant volume. So that should be equal to N1 CV1, N2 CV2, N3 CV3 by N1 plus N2 N3. So number of moles, let it be N. Hydrogen, diatomic gas, fire by 2, N2N, CV2, diatomic gas, fire by 2, 3N, okay, fire by 2. Number of moles 1:1:3. So solving this, I'll get the CV of a mixture. This is, so what we got is like a CV of a mixture. Okay, after getting this, what we do is okay, this will substitute in the this one. So what is this? Like a Cp minus Cv equal to, from Mayer's equation, thermodynamic Cp minus Cv equal to R. So Cp equal to Cv plus R. Then, so what is Cv of a mixture? 5R by 2. Solving this, we'll get the 7R by 2. Then the adiabatic exponent of gas. So what is gamma? Gamma, we are going to call it as adiabatic exponent of mixture. It is. So what is gamma? Cp by Cv. Do we know Cp of a mixture is? Do we know Cv? So I'll get the gamma. Then similarly, I should calculate I got the gamma. Similarly, I want the molecular mass of the mixture. So for that, N1 M1 plus M2 M2, this one. So N1 molecular mass of hydrogen 2, that of oxygen 32, linear carbon dioxide, also the carbon dioxide will be 44. So solving this, I'll get 33.2 gram per mole. Okay, we'll get this one. Okay, now what is the condition given? If the temperature of the mixture inside the cylinder varies linearly from T1 to T2, means at one end the temperature will be T1, at other end will be T2. So if you want, you can take help of graph also. not visible. I'll change some other color. Yeah. So if you look at the curve, so linear. So shall we take this T1? This is T2, T. Able to get this one. So what is the slope of this T1? It varies linearly from T1 to T2 is telling. Okay, I'll do one thing. Yeah. So find this is, so T2 minus T1 by L should be equal to T minus T1 by X. That I rewritten in this way. So what is the slope here? T2 minus. What is the expression for T? Will be finally equal to this much. Solving that. Okay, I got now the temperature of the gas as a function of distance. So I think I can justify this. Put X equals 0, temperature is T1. Put X equal to L, the temperature will be T2. Justified. Then let's come to the here that the value of T I'm going to substitute here. Okay, fine. So what is T equal to T minus T1 X by L? Then, okay, what is like a, let me expand further. So this will become gamma T1 gamma T1 minus T2. T1, T2 are constant. So therefore, there's everything, I'll call it as alpha. There's everything as beta. This quantity, it will help us a lot in calculations. So we'll just treat, we'll replace them by a symbols because all these are constants. Okay, no. So what is the expression for V? V is the speed of sound. Speed of sound in the mixture. So then this V, I'll write it as rate of change of displacement dx by dt. Then further dx by dt equal to alpha minus beta x. So let me integrate this dx. This I'll send it to LHS. Alpha minus beta x dt. Okay, this I'm going to integrate. So the integration of this will be minus 2 by beta root of alpha minus beta x, this one. The integral of this one. The value of this integral of dx by under root of alpha minus beta x will be this much. Substituting upper and lower limit, finally, I'll get expression for time. Then later on, you substitute alpha and beta, like what we did here. No? So this was alpha, and this is beta. Okay, this will be our final answer. Okay, it's just simple, only the integration little bit you may find difficult. Okay, got it now. So first, what happens when a sound wave propagates in a mixture, what you should do? You are supposed to calculate gamma of a mixture and molecular mass of a mixture. Okay, that's what we did. Gamma of a mixture and molecular mass of mixture. Then if it gives any condition, temperature varies linearly. Okay, that you bring idea from here. Okay, this one. So they're about the integration.